Okay, let's dive into this. We're going on a journey to find that elusive edge in the wild world of finance. We're going to get inside the heads of the quants. These are the physicists, mathematicians, and computer scientists who look at the markets and don't just see chaos, they see a puzzle, one they believe can be solved with enough data and the right math.
I mean, if you're not a quant, you look at a chart like this is S&P 500 returns, and it just looks like noise, right? Pure, unpredictable, random chaos. It's a jumble of dots that seems completely impossible to make any sense of, let alone predict where the next one's going to land.
But what if it's not random? What if buried deep inside all that noise there are hidden patterns, structures, a secret code just waiting to be cracked? Well, that question right there, that's the obsession at the heart of quantitative finance. It's all about using math and models to find logic in the madness.
So where do you even start? Well, our story really begins with one of the first and definitely one of the most famous attempts to bring logic to the market. It's a groundbreaking formula that you can really think of as the first hero in our story.
And this is it, the Black-Scholes model. I mean, this was a huge leap forward. Before this formula came along, pricing an option, which is really just the right to buy or sell a stock later on, was more of an art form. It was all gut feeling, intuition. This model, it changed the whole game by giving everyone a rational, repeatable way to do it.
So, the model itself is built on 5 key ingredients. Now, 4 of them are pretty easy to find. The stock's price right now, the option strike price, how much time is left, and the risk-free interest rate. But that 5th one, sigma, or volatility, that's the secret sauce. It's the one piece you have to estimate, and it's basically a measure of how much a stock price bounces around.
And this shows you the kind of heavy-duty thinking behind it. I mean, just look at this thing. The formula is frankly intimidating. It's a beast of Greek letters and advanced math that came from fields like thermodynamics. They were literally using the physics of how heat spreads to model the random walk of stock prices. Insane, right?
But here's the beautiful part. All of that brain-melting complexity, it gets boiled down into something so simple, so elegant. In the real world, a quant isn't scribbling this out on a chalkboard. No, they just call a single function in their code, like this one. The theory becomes a tool. It's pure magic.
But, every great story needs a conflict. And for Black-Scholes, that conflict came when its beautiful, clean theory slammed right into the messy, unpredictable real world. See, the model had a flaw, a really critical one.
So here's the Achilles heel. The model's elegant math was built on this one huge and, it turns out, very wrong assumption that volatility, our secret sauce, was constant, that it never changed. But that's just not how the market works, is it? The market has moods. Wild, volatile days tend to clump together, and calm periods tend to follow other calm periods. This volatility clustering was something the model just couldn't handle.
So how do you fix that? Well, you build a smarter model. Enter GARCH. This is the next evolution, and it was designed specifically to understand the market's moods. Instead of pretending volatility is one static number, a GARCH model says, hey, volatility changes, and yesterday's volatility gives us a clue about today's. It knows that shocks can stick around for a while, but that eventually things tend to settle back down.
And this isn't just theory. The proof is right here in the numbers. Just look at what happened during the 2008 financial crisis. A simple model that assumed constant volatility, it predicted you'd have a catastrophically bad day about 1% of the time. In reality, it happened a jaw-dropping 15% of the time. The model completely, totally failed to see the risk. The GARCH model, on the other hand, it performed almost perfectly. And that's the whole point. In a crisis, understanding how volatility changes is everything.
Okay, so we can get a better handle on a single stock's risk. That's great. But what about the bigger picture? What are those hidden currents that seem to pull entire sections of the market, or even the whole market, up and down together?
That's where factor models come into play. The idea here is pretty simple, actually. You can break down any stock's movement into 2 parts. Part 1 is its own unique risk, like a pharma company's stock tanking because their big new drug failed. That's all on them. But the second part, which is often way bigger, is its exposure to these broad market factors, things like interest rates going up and dragging down almost every tech stock with them. So the multi-million-dollar question is, how do you find these hidden drivers? Well, quants have a whole toolbox for this. If they have a hunch, like, I bet oil prices are driving these stocks, they can run a regression to check. But what's really cool is they can use powerful techniques like PCA to just dump all the stock data into a computer and let it figure out what the most important hidden forces are. even if we don't know what to call them.
Now, all these amazing theories, Black-Scholes, GARCH, factor models are fantastic, but how do you actually put them to work day to day? Let's take a look at the tools of the trade.
For decades, long before Python and R were on every desk, the entire financial world pretty much ran on one thing, the humble spreadsheet. Yep, Excel was the original quant sandbox. It's where these incredibly complex ideas were first brought to life, one cell at a time.
And this was the classic workflow. You'd lay out your whole problem in a grid, just like this, calculating all your potential returns. Then you'd fire up a powerful built-in tool, like Excel Solver, to do the heavy lifting, to find that one perfect portfolio or the exact volatility you needed to make your model match reality.
But here's the thing about the quest for an edge. It never, ever stops. And today, the frontier has moved way beyond the spreadsheet and traditional stats. It's moved into the world of machine learning.
This quote from Macro Synergy just nails it. The future isn't just about plugging new numbers into old formulas anymore. It's about using these incredibly powerful machine learning tools to find complex, hidden relationships in the data that the old models could never, ever hope to see.
So, take something like an autoencoder. It sounds complicated, but think of it like this. You feed a neural network a massive amount of market data. Then, you force all that information through a tiny little bottleneck. The squeeze forces the network to learn the absolute most essential patterns, to find the pure essence of what's driving a market. That compressed essence, those are your hidden factors.
And what's really wild is how these new models work. They use a trick called regularization. So think of it like this. Imagine a student who just memorizes every single question and answer from last year's test. They'll ace that old test for sure, but they'll probably fail this year's new one. Regularization is like forcing that student to learn the underlying concepts instead of just memorizing. Their score on the old test might actually go down a little, but they'll be way more prepared for the future, for data they've never seen before.
Which brings us to one last, really big question. The market isn't a physics experiment. It's a living, breathing, adaptive game played by millions of intelligent people. So, as our models get better and better at finding an edge, does the market itself just change the rules to make that edge disappear? Is this quest for an edge a race that can never really be won?